Measures of positions for group data. Measures of positions that divide a distribution into 4, 10, and 100 equal parts are called quantiles or fractals. So when the number of statistical data is large, its presentation can be transformed into something more compact. We know that the larger number of data, the more precise the information will be. And such information can be summarized and displayed by means of appropriate tables. So the group data are the data that have been organized into groups from the raw data so that a frequency distribution of those groups serves as a convenient means of summarizing or analyzing the data. First, we have the quartiles. The score points which divide a distribution into 4 equal parts. There are 3 quartiles denoted by Q sub 1, Q sub 2, and Q sub 3, which are the first, second, and the third quartiles respectively. 25% of the distribution fall below the first quartile, 50% fall below the second quartile, and the 75% fall below the third quartile. The graphical representation of quartiles shows that 25% of the data is less than or equal to Q sub 1 or the lower quartile. And the Q sub 2 is already the median of the given data. And then 75% of the data is less than or equal to the Q sub 3 or upper quartile. In solving quartiles for group data, we can use the same way as we have solved the median for group data. Let us have example. Calculate the lower quartile or the Q sub 1 of the mathematics scores of 50 students. So given our table, we have the scores 21 to 25, 26 to 30, 31 to 35, 36 to 40, 41 to 45, and 46 to 50. And then for the frequency, we have 6, 12, 9, 11, 8, and 4. In computing the quartiles of group data, we have to follow a certain formula. So the first step, we determine the lower boundaries or the LB. So given our table, so from our given, this will be known as the class intervals, wherein we have here our lower limits and our upper limits. Now, since we are only looking for the lower boundaries, we can get this by subtracting our lower limit by 0.5. So the first one is 21. So 21 minus 0.5, that's equal to 20.5. The same manner with 26 minus 0.5, that is equal to 25.5. 31 minus 0.5, it is equal to 30.5. 36 minus 0.5 is equal to 35.5. 41 minus 0.5 is equal to 40.5. And 46 minus 0.5 is equal to 45.5. The next step is determine the cumulative frequency or the CF. So given our less than CF, so we'll be referring to the given frequencies. So the first one is the frequency of the smallest class intervals or the class limits. So we'll just copy our 6. And then to obtain for the next less than CF, we'll be adding our 6 to 12. So we have 6 plus 12 is equal to 18. And then the same way, 18 plus 9 is equal to 27. 27 plus 11 is equal to 38. 38 plus 8 is equal to 46, and then 46 plus 4 is equal to 50. And take note, our highest less than CF here will be the total frequency. So the sum of the frequencies here will be equal to the highest less than CF, which is 50. The third step is calculate the Q sub 1 class. So given again our table, our 50 will be the total number of frequency. Even adding the number of frequencies here, this is equal to 50. And then since our 50 here refers to n, we are looking for Q sub 1. Our 1 here will refer to as our k. So again, our n is 50 and our k is equal to 1. We can now solve for the Q sub 1 class using position of Q sub k is equal to k times n over 4. It is 4 because we again using quartiles. So by substitution, our k is 1 times our n, which is equal to 50, divided by 4. So 1 times 50 is 50 over 4 is equal to 12.5. So the position of Q sub 1 is equal to 12.5. Now, for the obtained value 12.5, we'll have to look at our less than CF column. So for us to locate the class interval where the Q sub 1 class is contained. So we can have 18 because here we have the 7th to 18th score. Therefore, its Q sub 1 class will be 26 to 30. The next step is solve the Q sub 1 using our formula. So the formula to be used will be Q sub k is equal to the lower boundary of the Q sub k class plus the quantity of k times n over 4 minus the cumulative frequency of the class before the Q sub k class over the frequency of the Q sub k class times the size of the class interval. So from here, identify first our given class size. That is the difference between two consecutive limits. So using 36 minus 31, our class size, it could be C or I. 36 minus 31 is equal to 5. And then again, we have obtained a while ago that our Q sub 1 class is 26 to 30. So we'll be using the frequency of 12, the lower boundary of 25.5, and again, the total number of frequency or n is 50. And for the less than CF, before, so since it's less than CF is 18, but what we actually need is cumulative frequency of the class before it. So before 18, we have 6. So we substitute to this given formula. Our Q sub k will be Q sub 1 is equal to, lower boundary again is 25.5, plus the quantity of our k, since we are looking for Q sub 1, the first quartile, k is equal to 1, times the value of n is 50 over 4, because we are dealing with quartiles, minus the less than CF before the 18, that would be 6, all over the frequency of the Q sub 1 class is 12, times the class size, which is equal to 5. Simplifying this, we'll start with the parenthesis or the grouping symbol. 1 times 5 is 50 divided by 4 is 12.5 minus 6 divided by 12 is equal to 0.54. Then multiplied by 5, that is equal to 2.7, and add to the lower boundary 25.5, our Q sub 1 or lower quartile value is 28.2. Now, to check this, we observe that the 28.2 as the value of Q sub 1 really fall in our class interval 26 to 30. Therefore, since Q sub 1, it refers to the 25%, Therefore, 25% of the students have a score less than or equal to 28.2. What about the deciles? Deciles are the 9 score points which divide a distribution into 10 equal parts. These are the 9 deciles which are denoted by D sub 1, D sub 2, D sub 3, until D sub 9. In such organization of data, 10% falls below D sub 1, 20% rather falls below D sub 2, and so on, and 90% falls below D sub 9. So the graphical representation shows that 10% of the data is less than or equal to D sub 1 or the first decile, and so on. Now, to compute for the deciles for group data, we'll be using the same manner. So let's have example. Calculate the 6th decile or the D sub 6 of the mathematics scores of 50 students. So given again the same table, we have the scores and the frequencies. So first step is to calculate the D sub 6 class. So from the table, we have already its lower boundaries and the less than CF. So we have our 50 as the total number of frequency. 4 plus 8 plus 11 plus 9 plus 12 plus 6 is equal to 50. And then since our 50 is the total frequency, this refers to our N. And our 6 will be our K. So to find for the position of the D sub 6 class, we use the formula of position of D sub K is equal to K times N over 10. So this time we'll be using over 10. It's because we are using deciles for group data. By substitution, our N is 50, our K is 6, so 6 times 50 is 300 divided by 10 is equal to 30. So the position of the D sub 6 class is equal to 30. The next step is locate the class interval where the D sub 6 class is contained. So again, we'll be using the less than CF. So our 30 will fall here at 38 because we have 28 to 38 score. So from this 38, we have the 36 to 40 as the D sub 6 class. The third step is solve for the D sub 6 using the formula. So this time, instead of having Q sub K, we'll be having D sub K pertaining to the deciles. And instead of having over 4, we'll have over 10. So the formula in finding the deciles for group data will be D sub K is equal to the lower boundary of the D sub K class plus the quantity of K times N over 10 minus the cumulative frequency of the class before the D sub K class all over the frequency of the D sub K class times the class size. So from here, from the given table, let us use 46 and 21 as our lower limits to find the class size. So 46 minus 41, that is equal to 5. And then again, we have our D sub 6 class 36 to 40. So the frequency to be used is 11. The lower boundary is 35.5. Our N again is 50. And the less than CF, instead of having 38, since we are finding for cumulative frequency of the class before the D sub K class, so we have 38 here, its less than CF before will be 27. Let us now substitute the given values. So using this formula, we have our K is 6 is equal to the lower boundary 35.5 plus the quantity of our K is 6 times 50 is our N over 10 minus our given less than CF before is 27 all over the frequency is 11 times the class size 5. Then let's simplify. 6 times 50 is 300 divided by 10 is 30 Minus 27 is 3 divided by 11 is 0.27. 0.27 times 5 is equal to 1.35. And as we add this to the lower boundary, 35.5, our d sub 6 or 6th decile value will be equal to 36.85. So as you have noticed, our 36.85 really fall in the class interval 36 to 40. Therefore, since we have d sub 6, we are pertaining to the 60%. So we have 60% of the students have a score less than or equal to 36.85. And finally, for the percentiles, these are the 99 score points which divide a distribution into 100 equal parts. These are the 99 percentiles which are denoted by P sub 1, P sub 2, P sub 3, and so on until P sub 99. In such organization of data, 1% falls below P sub 1, 2% falls below P sub 2, and so on, and 99% falls below P sub 99. So this graphical representation shows that 25% of the data is less than or equal to P sub 25 or the 25th percentile, and the same way with the others. So in solving the percentiles for group data, we'll have the same way, but instead of having Q sub k, D sub k will be having P sub k to denote percentiles. So let's have an example. Calculate the 90th percentile or P sub 90 of the mathematics scores of 50 students. Given the same table with the same scores and frequencies, the first step again is calculate for the P sub 90 class. So we have already added the lower boundaries and the less than CF. Now the total number of frequencies will be 50, and we'll be looking for the 90th percentile, so that's our K. So we have position of P sub K is equal to K over K times N rather over 100. So we'll be using 100. It's because we are dealing with percentiles. So by substitution, our K is 90 times our N is 50. 90 times 50 is 4,500 over 100 is equal to 45. So the position of P sub 90 is 45. Next step is locate the class interval where the P sub 90 class is contained. So again, we have 45. We'll refer to the less than CF. And for the 45, we have the 46. So that is for the 39th to 46th score. So with that, our P sub 90 class will be 41 to 45. The next step is we solve for the P sub 90 using the formula. And then we have to identify our class size. So we can have 26 minus 21, that is equal to 5. And again, our P sub 90 class is 41 to 45. So the frequency is 8. Its lower boundary is 40.5. The total frequency is 50. And the less than CF before this 46 is 38. So we substitute the values, but instead of having Q sub k or D sub k, we'll have P sub k for the percentiles. So we have P sub 90 is equal to our lower boundary is 40.5 plus the quantity of our K is 90 times our N is 50 over 100, which is equal to 45, minus 38 divided by 8 is equal to 0.86. And then 0.86 times 5 is our class size. That is equal to 4.3. And then we add this again to the lower boundary. 40.5 plus 4.3 is equal to 44.80. So the P sub 90 or the 90th percentile is equal to 44.80. And this is actually fall in our class interval 41 to 45. Therefore, 90% of the students have a score less than or equal to 44.80. Let's try this. Calculate the Q sub 1 given the frequency distribution table. Okay, let's check. So again, for our given table, we have our N as the total frequency is 80. We are looking for K, which is 1, Q sub 1. And then for our class size, 70 minus 67, this is equal to 3. So our C is equal to 3. And then for our given position of Q sub 1, we have 1 times 80 is 80 divided by 4 is 20. So our 20 will fall here. This will be the 13th to 24th score. So our Q sub 1 class is 55 to 57. And then our lower boundary is 54.5. Our less than CF before to be used will be 12. And the frequency is 12. The lower boundary is 54.5. And then as we substitute, we have 54.5 plus 1 times 80 over 4 minus 12 divided by 12 times 3. So 20 minus 12 divided by 12 is 0.67 times 3 is 2.01 plus 54.5 is equal to 56.51. So our Q sub 1 value is equal to 56.51, which is actually fall in the 55 to 57 class interval.